Okay, good morning. It's September 17, 2023. The time is around 3:37 EM. Okay, my topic for this session will be my topic. It will still be college algebra, and this will now be lesson number 64. We are almost done with college algebra. So for those of you who are following my topic on college algebra, we are running smooth. Okay, let's proceed. The title of the topic for the session will be College Algebra. This is now lesson number 64. And the title of the topic is inverse functions. What is inverse function? Inverse function, it's the same as the inverse is synonymous to the so-called reciprocal. Like if we got a function y equal to a cosine of x, what will be the inverse function of cosine? Actually, we could solve that one. I will be trying to solve that problem on the next session, okay? But for tonight, I will be solving a different problem, okay, involving still inverse functions. Okay, let's try to bring out how to, or let's try to bring out the concept on how to get inverse functions. Concept. Two functions f and g are inverses, okay, of one another. Okay, there are two given conditions here. If that function f, if we try to substitute the value of g of x, okay, that's the concept. We are given a function f, and if we try to place a value for that function of x with the value g of x, if we try to simplify, the result should be x. Okay? For this f to be an inverse function of a g function, on the g function, that g function, if we try to substitute the value of f of x under that g function, if we try to simplify it again, the result will still be x. If they are the same, we could say that they are inverse. They are inverse functions. Okay, that's the condition there. So there will be two functions here, and we are comparing values that if we try to get the value of the other function, we place it on the other, what will come out will be x. And for the other one, if we try to get the value of f of x, we place it on the second one. If after simplification, what comes out is still x, we could say that function f and g are actually inverse. Oh, that's the meaning of that one. It's hard to, what you call this, visualize this concept without presenting an example problem. So to visualize this concept here, and to practice our mind to accept that concept, okay, let's try to bring out an example problem. Example. Find the inverse of, we are given a function x. F of x is a quadratic equation, x squared plus 2x plus 1. The problem is asking what will be the function, the inverse of this. The inverse of this is actually f to the negative 1 of x. Okay? We are solving for the inverse of this. This is actually to the power 1, but if the power is actually a plus 1, we don't usually place it. For the inverse, for us to recognize that it is an inverse function, we place the exponent negative 1. So if we try to read this one, this is the inverse function of x. Inverse function of x. With this negative 1, we read it inverse function. Without the negative 1, it is just simply f of x. Okay, the problem is asking what will be f to the negative 1 of x of the given function of x. Okay, let's try to bring out the solution. Actually, there are 5 steps on how to bring out or compute for the inverse function of a given function. Step 1, replace f of x by a second variable y. This is y. Okay, so that's step number 1. So the left hand side, which is f of x, we replace it by a second variable y. Okay, so after the replacement, what comes out is actually y equal to x squared plus 2x plus 1. Okay, that's step number 1. Step number 2, interchange x and y. Okay, interchange. For every x, replace it by y, and for every y, replace it by x. Okay, so there is one y on the left, so we replace it by x. And there are quadratic equations on the right, so replace all x's by y, so it will become y squared plus 2y plus 1. Okay, so we interchange already, right? Step number 3, solve for y. Okay, unluckily the highest exponent of y is actually quadratic, so we are trying to solve a quadratic equation involving y. So rearranging this one, am I still on camera? I will rewrite this one. I will put this on the left. So this is y squared plus 2y. This is plus 1. We will transpose this one to the right. Okay, then we rearrange it. So this should now be, after the transposition, this will now be negative x. And this should be equal to 0. We combine 1 with x. Okay, this is y squared plus 2y. And we combine 1 with minus x. So this is under one quantity, and this should be equal to 0. Actually, what comes out is a quadratic equation. Okay? If we are trying to solve a quadratic equation, and this is not factorable by inspection, or you could do by completing squares, but we will go directly with the solutions, solving by using the quadratic formula. So if we try to solve this by quadratic formula, we need the coefficient of the square term, the coefficient of the y term, and for the meantime, we treat x as constant. It is not constant, but for the meantime, we treat it as constant. So the pure c is actually 1 minus x. So if we try to specify the coefficients of the quadratic equation, a will be 1, right? B will be 2, and the value of c will be the quantity 1 minus x. So y now will be equal to negative open quantity b plus or minus the square root of b square. B square is actually 2 square minus 4 times the value a, which is 1, and the value of c is actually 1 minus x all over 2 times 1. Simplifying this one, negative open quantity 2, so this will now become negative 2 plus or minus. Well, we simplify the terms inside the radical. 2 square is 4, minus 4 times 1 will be negative 4, and then negative 4 times minus x will be plus x. So actually, this 4 here cancels, right? So what remains inside here, under the radical, will be the square root of 4x. So this will be 2 square times x. So 2 will be perfect square. So this will become 2 the square root of x. X should remain inside, okay? So y now will be negative 2 plus or minus. We bring out 2 already, this is 2, the square root of x over 2. Okay, we divide the common denominator for all the terms of the numerator. So minus 2 plus 2 will be negative 1. A plus or minus 2 the square root of x, the coefficient cancels, right? So y now will be equal to negative 1 plus or minus the square root of x. Okay, there are 2 possible values of y because it's a quadratic equation. So by using the positive sign, y sub 1 will be negative 1 plus the square root of x, and y sub 2 will be negative 1 minus the square root of x. Okay? That is step number 3, solving for y. Okay? Step number 4, replace y by f to the minus 1 of x. F to the minus 1 of x is actually the inverse of x. Right? It's negative 1. So from here, there are two y's, so there will be 2 f to the minus 1 of x. The first value is the inverse function of negative 1, the inverse function of x. If we try to read this one, this is actually y, because we replace y by this. So the inverse function of x, the number 1 value is actually negative 1 plus the square root of x. This is also inverse, sorry for this one, this should be negative. The inverse function of x, the second value is negative 1 minus the square root of x by using the second value. Okay, so these are actually our answer now. Okay, but we must have to verify it if they are really correct. How do we verify? We'll go back to the original equation. F of x is actually x squared plus 2x plus 1, right? So, function, because according to the concept, if the value of the inverse is to be substituted on the original function, what comes out will still be x. Okay, that's the concept. Since we computed two values of inverse function, okay, we'll verify first the first one. F, okay, the computed inverse is actually negative 1 plus the square root of x. By using the first value, the first value here is actually negative 1 plus the square root of x. So by using the original function of x, substitute the computed inverse function. Okay, that's the meaning of the concept there. Minus 1 plus the square root of x quantity square, we are following the given function, plus 2 times the value of x. The value of x is actually the value of the inverse function. Okay, negative 1 plus the square root of x plus 1. Expanding this one, negative 1 square will be positive 1. The middle term will be negative 1 times the square root of x times 2. So this should be negative 2 the square root of x. Am I still on camera? And the square of the square root of 1 will just be simply x. Right? So we have squared this binomial already. 2 times minus 1 will be minus 2. And 2 times the square root of x will be 2 the square root of x plus 1. Then try to simplify. This is minus 2, right? This is plus 1. This is plus 1. So they cancel out. Right? This is minus 2 the square root of x. This is plus 2 the square root of x. They cancel out. What remains after the simplification? It is x. It's okay. Because according to the concept, if we try to substitute the value of the inverse function on the given original function, if what comes out is x, okay, we could say that the inverse function is actually the inverse of the given function of x. So this is okay, right? We satisfy this one. Next value. When x is equal to negative 1 minus the square root of x. Because there are two values of inverse functions, right? So function of the second inverse value of x is actually negative 1, negative the square root of x, quantity square. We are following the format of f of x. Plus 2 times the inverse computed inverse value is negative 1 minus the square root of x plus 1. Squaring this one, okay, a negative 1 square will be a positive 1. The middle term will be a negative 1 times a negative x. A negative will be positive, but it should be multiplied by 2. So this is plus 2 square root of x. The square of the last part is actually the negative, the square root of x. So we square it, okay? So it will become a plus still. Even though this is negative, but we will square it, it will not be plus. No more radical, right? And 2 times minus 1 will be minus 2. And minus 2 the square root of x. 2 times minus the square root of x is minus 2 the square root of x plus 1. Oh, let's try to simplify. This is plus 1. This plus 1, it's plus 2, right? This is minus 2. So they cancel out. Right? This is 2 the square root of x. This is minus 2 the square root of x. Again, they will cancel out. What remains? It is x. So after the substitution of the second value of the inverse function on the given original function, what comes out is still x. So we could say that the second inverse function minus 1 minus the square root of x is actually the inverse of the given quadratic equation. Even on the first value, when the value is negative 1 plus the square root of x, what comes out is still x. So we could say that the first inverse function is actually the inverse function of the given quadratic equation. Therefore, the given function of x, which is x squared plus 2x plus 1, the inverse function is actually two values. It is this. Okay? The inverse function of this one is actually negative 1 plus or minus the square root of x. Because when these values are substituted back here, what comes out, according to the concept, it should still be x. Okay, that's it, guys. That's the concept of the so-called inverse functions. I will repeat it before we will go for this morning. There are two given functions here. The meaning of the inverse function is that if we try to get the value of the g of x of the second one, we substitute it on the first function. If what comes out is x, okay, take note of that one. Then take the value of f of x, substitute it on the second function. So this is g, so this should be f of x. If we try to substitute it, then try to simplify, what comes out will still be x. X on the first one, x on the second one. Therefore, the two functions are actually inverse functions. Okay, that's the concept of inverse functions. Okay, this is Professor David J. De Los Reyes from Los Angeles. Good morning. This is the topic on inverse function. It's easy, okay? Good morning.